Hey everyone, my name is Billy Korando, and welcome to Java 1. So, I'm a developer advocate with Oracle, part of the Java Developer Advocacy team, and today we're going to be looking at the Programmer's Guide to JDK Flight Recorder. If you have any questions or later on you can think of them after seeing this recording, you can reach out to me at Billy Korando on Twitter, or also you can send an email to me at billy.korando@oracle.com. So, with that said, let's go ahead and get started. So the first part is you might be wondering, what is JDK Flight Recorder? We're just going to kind of cover this briefly. If you do really want to in-depth on how to fully get started going with JDK Flight Recorder, you may want to check some other session out, as we're going to be more focusing on the programming APIs, but I will kind of at least get some level setting in here. So what is JDK Flight Recorder, or JFR for short, which I'll be kind of generally referring to it as now? So its history goes all the way back to JDK 7. And back then it was called Java Flight Recorder, and it was actually even goes back a little bit farther to JRocket. Now the history behind why JFR was developed was, well, a bit two reasons. One reason was that the fact that customers, when kind of reporting issues back to JDK engineers, were having difficulty maybe providing accurate information that JDK engineers could use to then describe to resolve an issue. And this could be performance or some sort of bug or something like that. Of course, you can say like, oh, we're running into some sort of slowness a few minutes into our application. That's not always super helpful to JDK engineers. So they needed a little bit more a better way of actually recording what was happening within the application. So that's part of why JFR was developed. The other part is actually for JDK engineers themselves. As every new release of JDK comes out, it gets a little bit better performance. Things like the garbage collectors improve a little bit in some areas. And JDK engineers are using JFR to actually do diagnostics and performance testing to see, does this change that they're making actually have the desired effect of improving the application's performance? So it's not just something that only customers use. Actually, JFR is quote unquote dog fooded by JDK engineers as well, which kind of helps with how it being a very robust and very usable application. So back in JDK 11, we actually open sourced Java Flight Recorder and renamed it to JDK Flight Recorder. So now you can actually use JDK Flight Recorder in production without having to have any sort of commercial license to use it like you would need to before. And the one really nice thing also is that it's actually built into the Java runtime. So you're not going to actually have to go out and download some sort of separate binary or use some sort of separate application to use JDK Flight Recorder. As long as you're using a hotspot version of JDK of the JVM, it has JDK Flight Recorder built in with it. So to get a little bit more into the technical details of JDK Flight Recorder, it is an event-based diagnostic and profiling tool. So diagnostic to, potentially finding some sort of bug or some sort of issue happening, and profiling, of course, because it can be used for doing performance testing to, improve the performance of your application. One really important thing, though, I think if there's anything you take away from this presentation, is that it has extremely low overhead of under 1% when it comes to using the default settings. So it's really meant to be used continuously in production. So definitely have a takeaway that you should consider turning on JDK Flight Recorder in production, when you kind of leave this presentation and go back to your work. Just because that's the goal of it. It's not necessarily just to be used only in a test environment or only in a test, or only on your local system. It's really meant ideally to be used in production to find when some sort of issue happens, with an application, that's been running for several days or several hours or something. It's good to have that flight recorder running then to diagnose what was going on. Again, that's kind of where its name is coming from, JDK Flight Recorder, just like a real life flight recorder that is always running for when issues or, potentially catastrophic issues like a crash happen, that is available to see what happens. It's not good if you can only go back and post hoc check things out. And of course, the JDK Flight Recorder, it covers events both happening within the JVM as well as the Java applications running on top of it. As I mentioned, it's an event-based diagnostic and profiling tool. And so as of JDK 17, there's over 150 events, and I believe it's over 160. I think it's like 165 or so default events provided as of JDK 19. And we can kind of see here some of these different events, like when a thread starts, when a thread has a dump down in it, when we're reading files or writing to files or reading from sockets or writing to sockets. All those events are recorded so you can kind of get a really good idea of what's actually going on within your application. And you can even create custom events as well, which we will get to a little bit later in the presentation. So how do we get started using JFR? It's already built in, but how do you start using it within your application now? There's several ways to use it. So when you launch an application, there is the Start Flight Recording VM option, and it can take a bunch of different values with it. In this example, I am giving it like a file name for the recording that this information is going to be written to. And in this case, I'm saying dump on exit to true. So whenever I exit this VM, it will automatically, or tell the JVM to stop, it will automatically create a recording file, in this case, simply recording.jfr when the JVM quits. But there's a bunch more options, like you can define which settings files you want to use. You can also define it to where different intervals by which recording information will be dumped out of the recording. Also, and this is one of the things I also really like about JFR, is it could be very easy to start up your Java application and maybe forget to turn on JFR. Maybe it is a application where performance is absolutely critical, and even losing 0.5% of performance might be too much in most situations. But then you start running into some sort of issue. It's actually nice that you don't actually have to restart your application to start JFR. You can actually start JFR on an existing running application. So in this case, you could use jcommand, jcmd, and then you would give the process ID of the Java application you want to have the JFR recording on, and then you do jfr.start. And this could also, again, take many of these same values that the Start Flight Recording option could take, such as file name, dump on exit to 2, whichever settings you want to use, and so on, to get information out of that application. But again, that's a already running application that you can do that on. You don't have to only start flight recording when an application starts. So in these examples, I am doing the dump on exit to true, but you, of course, also don't want to have to stop an application just to see this recording information. And it is possible to take that recording information out of it without having to stop the application. And this is also non-destructive. So you can just do jcommand, again, the process ID for your Java application, JFR dump, and then that will extract out information from that recording file. And like I said, it's non-destructive, so that existing information will still be written to it as well. You can also, as we kind of alluded to a little bit, in the settings, you can also have it to where dumps will be performed at regular intervals. It could be by file size. It could be by date or time. So you can have it be like, okay, whenever a recording file gets to 50 megabytes in size, that will have it be dumped out to a new recording file, or maybe every hour or some other interval. That is when a dump will be performed. And, it could be, so if you have like 50 megabytes in 1 hour, whichever of those two that's hit first is when a new dump will be performed. So that's pretty flexible and can work for a lot of different situations. What works best for you will depend upon a lot of the variables of the application, your performance requirements, and so on. So analyzing recordings, you get these out, what are you going to do with them? So there is the JDK Mission Control, which is a free and open source tool. It used to be part of the JDK, but now it's its own separate binary and downloadable. And JDK Mission Control is good for providing a kind of a high-level overview of your application. You get an overall look. It has a lot of great views for like showing like the memory usage, thread usage, garbage collections, and when garbage collections are happening and all that. So it has really great views for that. It also has tools for providing recommendations on maybe ways to improve your application. They're still coming along with how good those recommendations are. And of course, it's a GUI. It's a graphical user interface. So if you're more familiar and more comfortable when working with a GUI, then also JDK Mission Control can provide an option for analyzing recordings in that way. There is also the JFR command line tool. Um, and of course, it's available for command line. So it's very low weight. You can also remote into some sort of application running in your servers and then run JFR against it to kind of analyze it. And it also allows you to quickly drill down to relevant info. GUIs are nice because you can navigate around with them, but sometimes it can be a little bit cumbersome if you really know exactly what you're looking for, but you have to maybe go through a few screens to get to it. In this example, let's say if I'm only interested in looking for all the thread start events, I can simply do JFR print, pass in events, and then just say I'm looking for JDK thread start event types from this recording, and you can quickly drill down that way. So that's one nice advantage the JFR tool has. But these tools are much more powerful than OSO, but that's for a different presentation. So as mentioned, there is also the ability to create custom events. So to simply create a custom event, all you really need to do is extend the JDK JFR Event class. And well, that is a custom event, but you probably actually want to do more than that. So first is you want to make sure you take advantage of using the metadata categories. And we see these up here with like category, label, and name. So name will be the name of the event, like we saw a little bit earlier with like JDK thread start. In this case, the name of this event would be simply my event name. Not a great name, but to demonstrate what is happening here. If I didn't provide a name here, then the default name would be the fully qualified class name of the event class. Categories, as you can see, this can take an array of strings, and definitely make sure to take advantage of these to provide different categories for whatever this event would fit into. So like in this example, I have like PII, so maybe this event could be storing personally identifiable information, and it's doing something with the business, and it's some sort of critical, like it's covering critical things that are happening within our application. Definitely make active use of these metadata, because it helps for when wanting to categorize events, or as we'll talk about a little bit later, filtering events out to make sure you're not sharing information you don't want to have shared. So when it comes to actually storing information, so you're noticing an occasional bug happening within your system. Maybe you want to capture information about what's happening. Someone maybe could be sending a null value or a special character that's causing a bug somewhere farther down your application. You want to capture that. You can provide many fields that can be captured then by this event type. However, there's only certain allowed fields. They either have to be one of the 8 primitive types, or string, thread, or class. But as the little asterisk notes, if you did provide another event, a different field type, like in a list or integer or something like that, then they would just be silently ignored. So it wouldn't cause some sort of issue if you try to capture some sort of field type that wasn't allowed. To then use this event within your code, you would create a new instance of that event. Then you would call that event name .begin, and then whatever you want to have to be checked for, you would have that. If there's any sort of values that you want to capture, then you would then of course call that event, and then whatever method that would then capture that information. But then at the end of it, you would then want to call commit. This is maybe a little messy. Certainly my tingling sense as a developer is like, okay, if you see all this in there, it might look a little bit heavyweight and a little bit messy within your code, but it's actually very all lightweight. So even it's a little messy in the code, it's actually not causing too much of a performance issue. If this event isn't even enabled, the JIT will actually just remove this code from even being executed, so it won't cause a performance impact that way. And then the begin and commit calls are very lightweight, so they shouldn't really be having much performance impact. Now, maybe depending upon what you're doing when you're capturing values, that could have some sort of performance impact, but that can also be handled appropriately. That's not necessarily anything with JFR itself. You can also configure events. So if I was to add like a custom event, like I showed at my event name, I can call JFR and then the new configure tool. This was added in JDK 18. I can say, okay, add this event to my configuration file, have it be enabled to true, and they can also set the threshold to 0 milliseconds. So there's various settings you can set for your events. Threshold could be a potentially very useful one. And what it is saying, between that begin and commit I showed earlier, there will be a timer to see how long it takes for the code in between that begin and commit to execute. And there could be a case where, like, okay, sometimes when we're making a database call, like 99% of the time they execute in under a millisecond or under 5 milliseconds or whatever, is an acceptable amount of time. But sometimes they take a whole lot longer. So what you could do is set that threshold to whatever that acceptable amount of time is to say 5 milliseconds, and anything under 5 milliseconds, that event isn't recorded. Anything over 5 milliseconds, that event is then actually captured and recorded. So that way you're not having to deal with a whole bunch of noise within your application. There's also a bunch of other settings, but threshold might be one of the more useful ones in there. Yeah, as I said, events time, begin and commit, and anything below that is not captured. So added in JDK 14, when I was showing earlier about dumping recording files, that's a very coarse-grained, very analog way of getting information out. Added in JDK 14, though, was a way of doing JFR Event Streaming. This can allow reading of data kind of live from a recording so that you can actually do some sort of monitoring on it. Maybe you're running a bunch of your Java applications within Kubernetes. Using JFR streams, you can maybe send some of that information out to an endpoint saying about like CPU usage, memory usage, or whatever it might be. And from there, JFR or Kubernetes or something, you could then take action at certain thresholds to either spin up or tear down instances of your Java application. But also keep in mind how the data is being streamed can impact overhead. That if you're populating that to endpoint constantly, that's having to serialize that data, which has performance impact. So at least something to kind of keep in mind there. There's a bunch of different ways to stream information. You can do it within process, so like just running within your current process to get information out of it. There's passive, to where you're just saying on the existing event types within your settings to what to do with them. And there's also active here, where you can actively enable or change the configuration for a setting for an event within your settings file. You can also do out of process. In this case, I am telling some sort of system to look to a recording file and then read data out of it. And then also I can maybe, for example, have it also do it based on reading it from some, like in this example, a JMX endpoint. One other really useful thing when it comes to this event streaming is it can also allow JFR to be used in unit testing. So in this is some very simple example here, I am having my service being tested, and I'm making some sort of call on it at some point to do something a business meaning value that I want to have checked. And I just tell my recording to start the stream at the start of the unit test and then end it at the end of the unit test. And from there, I can then check that stream for how long it's taking certain events to fire, how many events are firing, and so on. But this is very useful in the world of performance testing, because performance testing can notoriously be very difficult. If you're running a performance test in a integration region, and in that integration region, both your application server and your database server are in the same region, then the network latency is going to be, pretty short for that because it's not going too far. But let's say in production, your application server and your database are in different regions, then that latency would be much longer. So there could be ways, if you did performance testing just on a deployed application, the very coarse-grained level of running like an end-to-end test in some sort of region, you could be trying to optimize performance in areas that really may not matter in production, because the bottlenecks could be in different locations. Whereas with your using JFR, really all that matters is the same JVM implementation being used across regions, because the performance and behaviors should be consistent across them, regardless of the underlying network and architecture and infrastructure beyond that. Lastly, I'm going to cover about filtering events. And this is also something very new that was added to JFR with JDK 19. So there are ways to, and this was added because JFR, as we saw, can collect a lot of information. And potentially, if you write in your own custom events, you might find you're accidentally collecting information you don't necessarily want shared. It may be fine to collect information and use it internally, but if you're sending a recording to JDK engineers at Oracle or somewhere else, or to some third party, you may want to make sure that sensitive data information is being removed. So added in JDK 19 is the JFR scrub utility, and it can allow events to be removed from a recording, like in this example with JFR scrub. And you can exclude by this example category. So anything with the PII, again, personally identifiable information category, would be removed from that recording, and then you would get a new recording file back saying, by default, the recording -scrubbed. You can also provide your own name for that output file, but the default will be just the recording -scrubbed of it. You can also tell it to only include certain events for recording. So in this example, I am just saying include any events with GC in it, with GC in the name, and so that way we can just limit only to garbage collecting events. If that's what you want to do, maybe you just want to focus it down to only certain specific areas, so you're not looking at so much noise within your recording file. You can provide multiple filters, and these work as and. So if I did include events for all GC types and then exclude a certain GC event type, that's a way of doing it. You can also provide multiple criteria, saying like include all GC events, and then also include thread starts and thread ends as well, or something like that. This is so you can provide multiple criteria. You can also, if you have some sort of advanced requirements for filtering out information, there is also the new API, the JFR.write, where you can check through the different events within a recording file and then have it filter out certain events as needed. Like in this example, I kind of had to simplify it so it can properly fit within the slide here, but it was like looking at CPU load, and if anything was at least over 95%, it would actually capture that recording or that event, but anything under that threshold, it would just ignore. So that's another tool, another part of the API that was updated with JDK 19 for filtering events. There's a whole lot more to these APIs beyond what I could kind of show during this relatively short 30-minute presentation. I would highly recommend checking out our release guides on this. There's a Flight Recorder API Programmer's Guide, which can give a lot more detailed information on creating streams or how to set up and customize events. One of my colleagues, Joachim Nordstrom, he put together a bunch of examples on using the JFR API. For example, the unit test I showed a little bit earlier, he kind of demonstrates how to use JFR for unit testing. So be sure to check out his GitHub at this link. And then finally, some of our documentation hasn't been fully updated yet, but if you want to see a little bit more on how to use JFR Scrub, you can check out the JBS ticket on that, which demonstrates how to use the JFR Scrub, including the programming API example that I showed just a slide earlier. With that said, I hope you enjoyed learning about the JFR Programmers API, and hopefully you start using JFR profiling your application soon. With that said, see you later.